Okay, today we're going to add to what we've been doing the past few days by taking it even another step further and doing conversions from mass to mass, which could also be labeled as grams to grams. Okay, for a mass to mass conversion, the reason we have to do these is in the lab, do I ever ask you to go measure the moles of something? Like go measure 5 moles of sodium. No, I usually ask you to measure the grams of something, which is mass. So we're going to have to start in grams and then usually end in grams so that we can know how much is really there. So we're going to add to our little picture we made yesterday of converting with your little help. So draw this again if you want, or add to the one you did yesterday. So the first step of any conversion would be going from grams to moles. And in order to go from grams to moles, you're going to use the periodic table. The next step would be going from moles of A to moles of B. And when you're converting from moles to moles, you use the equation. Okay, and then the last step would be going from moles of B to grams of B. And here again, you use the periodic table. So keep this in mind, keep this out and look at it to help you while we do some examples. So here's our first example. How many grams of chlorine can be liberated by the decomposition of 64 grams of gold chloride? So we're going to start right here. 64 grams of gold chloride. Okay. And then grams is on top, so grams has to go on bottom. And we always say how many grams are in 1 mole of that same substance. So remember yesterday I talked about how something on the top and the bottom has to be the same. And in this case, it's AuCl3. All right, so how many grams are in gold chloride? We have to use our periodic table and find the mass of gold, which is Au, and I'm going to write it over here, 196.967. And then chlorine, there's 3 of them, so we'd say 3 times 35.453, and we add that together and put it over here. So I'm going to do that with my calculator, and you do it too. And I got 303.326, and that's what goes down there. So we're nowhere near done because we just did this step, grams of A to moles of A. So what's the next step? We have to go to moles of B. So moles of A, or AuCl3, is on top, so that goes on bottom. And then we go to moles of B, or in this case, chlorine, which is the Cl2. Okay, and where do we get those numbers? Which I covered up one of them, but where do we get those numbers? From the equation. How many moles of AuCl3 are there? 2. How many moles of Cl2 are there? 3. So that's our next step. Then our last step is to go from moles of B to grams of B. So moles of Cl2 is on top, so that's what's going to go on bottom. And then we go to grams of Cl2. But we always say how many grams are in 1 mole. All right, if we're going from moles to grams, we have to use the periodic table. So we're going to have, I'm going to do it over here, 35.453 times 2. So do that on your calculator. And I got 70.906. Okay, now that we have all those numbers filled in, we have to do the math. Okay, so we're going to start with 64, and then we're going to divide by 303.326, multiply by the 3, divide by the 2, and multiply by the 70.906, because you multiply across the top, divide by the bottom. And in the end, I'm going to put my answer up here. I got 22.44 grams of Cl2. So that's my answer. All right, let's try another one. Okay, this one's actually 2 parts, so we're going to do both parts. But given this equation, calculate the mass of PbI2 produced by reacting 30 grams of Ki with excess PbNO32. This excess part doesn't matter. It's just saying there's extra of it, so it's not important. All right, so start with what we know, which is 30.0 grams of Ki. What's on top goes on bottom. And then we always go from grams to moles, and it's how many grams are in 1 mole. So now we have to add up the mass of Ki. K is 39.098. In I, we have 2 of those, and they are, I'm sorry, we just have 1 of those. 1. And they are, it is 126.904. So we just add those 2 things together. And we should get 166.002. So that goes down there, if you can read my handwriting. All right, so now we're in moles of Ki. We got to keep going. Moles, we went grams to moles, and now we go moles to moles. So moles of Ki was on top. Moles of Ki has to go on bottom. And then we're going to PbI2, so moles of PbI2 has to go on top. And then we fill in our numbers. So this PbI2 is a 1 and Ki is a 2. Okay, now we can move on to the next step, and we go moles to grams. So moles of PbI2 is on top. That's what goes on bottom, and then we go to grams. Okay, so we're going to have to add that up from the periodic table. And Pb is 20, let me find it. Okay, 207.2 plus 2 times that I, which is 126.904. And then we're going to have to add those together. So I'm going to do that on my calculator. And I got 461.014. So then I'm going to divide, multiply to get my answer. So do that. And when I did that, I got 41.66 grams of PbI2. So that's my answer. Okay, that's it. Let's see what the next question is. Okay, it's the same equation, but it says calculate the number of moles of PbI2 produced by 23.8 grams of Ki. So we're going to start with 23. Let me fix that too. In fact, I'm just going to start over. Okay, 23.8 grams of Ki. So grams is on top, grams has to go on bottom, and then we say how many grams are in 1 mole of the same thing. And we add it up, and remember our K was 39.098, and our I was 126.904, and we add that together. I don't remember, so I'm going to do it again. 166.002. Alright, so we're in moles of Ki. Then the next step, moles of Ki is on top, so moles of Ki goes on bottom. And then moles of PbI2 2 has to go on top. And those numbers come from the equation. So there's a 2 down here and a 1 up here. And then I'm done because look, it says moles. So know when to quit, okay? Don't work harder than you have to. Know when to stop. So we're going to do that on our calculator. 23.8 divided by 166.002 divided by 2, and we get this 0.072 moles of PbI2. And we're done. So I threw in a problem from yesterday just to make sure you're paying attention and you know when to stop. So you have this thing, grams of A, and I know I've drawn this like 20 times, but I want you to get it. Moles of A. Moles of B. Grams of B. All right, so let's say you're starting with moles and you're ending with grams. Then you would just take this part out and start with moles and end with grams. So it'd just be 1, 2 steps, okay? Or if you're starting with grams and ending with moles, you take this part out and go here. So you just have to know how to use that and when to stop. Okay, let's do another example. I'm not sure which of these examples you have. If you get to an example that I'm doing that you don't have, you can write it down to help you out. Okay, on this one, we're starting with 12 moles of NaClO3, and we're going to grams of O2. So we're already in moles. So moles is on top, moles of NaClO3 has to go on bottom. And then we're going to eventually O2 in the end. So we have to go to moles of O2 first. And we get these numbers from the equation. There's 3 O2s and 2 NAs. Okay, NaClO3. So now we're in moles of O2, but we're not done because we need grams of O2. So 1 mole of O2 is how many grams of O2? So you have to take the mass of oxygen and multiply it by 2. I'm going to put it up here, 31.998. Okay, and then I'm done. That's it. Okay, that one was only, 2 added steps. So do your calculation. So I did 12 divided by 2 times 3 times 31.998, and I got this. 5, 7. Did I hit something wrong? No. 575.964 grams of O2. Okay? Okay, last example. Given the following equation, how many grams of NaCl are produced from when 80 grams of O2 are produced? So we're starting with 80 grams of O2, and then we're going to go all the way to grams of NaCl. So this one goes all the way across. So the first step is grams to moles. Whatever's on top goes on bottom, and it's always how many grams are in 1 mole. We just did that one. Or if you don't remember, you do 15.999 times 2. All right, now we do moles of O2 is on top, moles of O2 goes on bottom, and we're going to NaCl, so we have to have moles because it's moles of moles. And we get these numbers, 2 NaCl's and 3 O2's. All right, one more step. Moles of NaCl is on top. So moles of NaCl goes on bottom. And then we're going to grams. And so it's always how many grams are in 1 mole. And if it's NaCl, we find the masses on the periodic table. Na is 22.99. Cl is 35.453. We add those together. And I got 58.443. Okay, that's an 8. All right, and then I'm gonna start with my calculations. 80 divided by 31.998 times 2 divided by 3 times 58.443. And for my answer, I'd get 97. Ooh, let me rewrite that. 97.41 grams of NaCl. Okay, now you're going to have a homework that combines what we've done this whole week. So try to answer it, and if you don't understand, try watching the video again.